Let me. So now we stop at um, the use of some simple statistics yesterday. So for today, we will continue by looking at inflation statistics that we talked about last time when we are discussing fundamentals of analysis. So today we are going to look at regression, correlations, and then look at the time where, if we have much time, then we talk about the ANOVA in a way, and a little bit of predictive statistics. So now, as you can see on my screen now, you can see that the data set I used yesterday, we still have it there in terms of the Google Forms that we have downloaded. So today, what we are going to do now is that we are going to also go back to our SPSS and look at look at the other things like inputting the data from the Excel sheet that we have. So like we did yesterday, we are going to have our A1 here now. Then we have the label. And don't forget that yesterday we used the questions that we have from the questionnaire we designed. So now we pick this first one, then we go back to our SPSX where we are going to have the label there. Then the value we had yesterday is 5, and it's going to be strongly agree. Then we have 4 to be, sorry, strongly agree. So we have 4 to be agree. Then we are going to have 3 to be strongly.
I can't hear you, Sal.
You can't hear me? Hello? Is it read one? Can you hear me?
So we can't hear anything. No.
You can't see anything or you cannot hear me. Which one? Hello? 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 Can you hear me? Hello? 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 Can you hear me now? Hello? 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 I have everything set up here, so I don't know what is happening. Can you hear me now? Hello? 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 Hello?
Hello, sir.
I'm asking you, can you hear me? All of you just muted your microphone. Can you hear me now?
I can hear you now. I can hear you now.
Hello, sir.
Hello, sir. We can hear you now.
I don't know why you are saying that you couldn't hear me before. So you do strongly disagree as 3 here now. Then we have 2 to be disagree. Sorry, we have 5 strongly agree 4, 3 strongly disagree, 2 disagree. Then we have 1 to be neutral. So that is the value that we have for our questionnaire. So now we are going to have this as the scale. Then we have A2, they retain the same numeric numbers. Then we go back to our Excel sheet, then we pick the next questions. So we have it here. Now, then we go back to Excel, SPSS, then you put it there. Then we retain this value here. So we have the scale. And 8.3 again, we have the question 2 from our Excel sheets. Then we go back to our SPSS. So we place it here now. Then you copy the same things there. Then we have A4. Then we retain the same thing. So we go back to our, is it A4? Sorry. A4. Okay, if it is A4, it means that I've mixed 1, 2, 3. So this should be for 3. Let me see. This should be for 3. Then, okay, sorry, I mixed this one. A2. A2, then A3 will be this. We have A3. Then we have A4. A4, then we go back to then we have A5. So we go back to our data. So we have the SPS. Okay. So now the value remain the same for all. The value remain the same. Then, like I did yesterday, now we go back to our data view. So I want to know, hello?
Hello, sir.
I want to know whether you can see my screen. The things I'm moving here and there. Can you see them?
Yes, sir.
So we copy the same thing like what we did yesterday. We copy to the 380 respondent that we have. Then we go to SPSS, then we paste it there to have the data. So our data is there now. So what we need to do now is to start running our analysis. So for today, we are going to regressions. And when you want to run regressions, you come to analyze here, then you scroll down. You can see this is regressions. These are the types that are available. We have automatic linear modeling, linear curve estimations, partial least squares, binary logistics, and then we have a multinomial logistics. But I'm going to talk about multinomial logistics here, and then talks about, binary logistics for now. We are talking about linear. Linear here is when you are looking at simple linear regressions. That is, when you have 2 independent variables and one dependent variable sometimes. Then it could also be 1 independent variable, 1 dependent variables in a way. So what we are going to do now is that when you click on regressions and you go to linear here, you click on linear. So this is the box we are going to get. Now, you now start deciding which one is dependent variable, which one is independent variable according to the data you have. Maybe our question is to understand the people who are accessing information through people around them and those who are getting information from current issue from the news. So we want to look at the link between these two now, for example. So what we are going to do is to pick this one that we want to consider information from the general public as independent. Why we see we are going to consider sources from information from the news as independent. And we click on this and move it to this box of the independence. So if you have multiple independent variables now, you move them here, while you have one dependent variable. Meanwhile, as we are looking at this now, we are looking at this as our dependent variables. So our assumption in our questions or hypothesis is that when people are getting information from the news sources, they are most likely to relay such information back to the other people around them, for those who are not having access to the information through the news media. That is what we are assuming according to this analysis now. So we now click on this, we take it to dependent sections. Now, the next thing you are going to do is to look at statistics here. So what are you going to have as the output of your analysis? So basically, you can see that this estimate and the model fit, they have already been accepted there in a way. So you leave them like that. These are the things that are very significant. That's according to this software. That's why they are there. So for you now to look for the others, then you now continue to say, okay, I want to get this. I want to get R square. I need this particular variable as well. Then I want to know the confidence interval to be 95 if you need it in your regressions analysis. That is that for that. Then the next thing you are going to do is that to click on continue. Then if you need a plot, you want to have linear regression plots. Yeah. So what you are going to do is to move this into this box, Y and X. Now, our independent is going to be the one that we have as the foundations. So when we have the X is usually horizontal, while the Y is vertical. So the one that we have as horizontal is going to be our independent variables, while the one we have as vertical is our dependent variable. So from here, I'm taking this to this box, then I will pick one of these. For example, you can pick this or this into this box. So it means that I need my results to come from plot background. So I can decide to say, I want the plot to be histograms in a way. Then you click continue. Now, if what you are doing is that you are trying to run this first set of regressions for further use later, then you can also come here that you want the values like this to come out and save it for you. It means that I want this unstandardized value to be saved and this to be saved in a way. But if I don't want to use the one I'm analyzing now for further analysis, then I need just to close it. I don't need it. So now the options, this is also usually there as the, what do you call it, as the default. Now, if you remember last time, I showed you where we have 95% confidence interval. So this is where we are going to look at the p-value. So if my p-value is not 0.5, then I will come here and indicate the one I want it to be there. But automatically, this software will give you this. So if it is like this, then you leave it and you continue. Now, this is another thing entirely. So I don't want us to go to this discussion for this one because it's a little bit complex for now, for you. Now, you now come here to look at the method that you want the regression to take. I want it to be enter, that is from the independent to dependent variable or dependent to dependent variable. But I want it to be backward regressions. That is, I want it to go to the back. But if your data is not what we call time series data, you don't need to bother yourself about stepwise, remove, backward, and forward. So you basically focus on enter. Then you click OK. Now, the next thing you're going to see is the results. I hope you can see the result now. Hello? Hello? I want to hear you. I want to hear you.
Hello, sir. Hello, sir.
Can you hear me now?
I can hear you.
Okay. So now, can you see the result that it is now displayed on the screen? Can you see the results?
No, sir.
You cannot see the result.
Yes,
You cannot see the result.
I'm seeing it.
I don't understand.
Okay,
I can see it.
Please
I can see it.
indicate when you are seeing the output. If you don't get anything from the output or whatever I'm showing you, please let me know. That's the best way for me to know that you are following. So now, this is going to be the output that we are going to have now. You can see those things we have selected.
I can see it. Oh,
Okay, good. Those things we have selected that we want to be there now, you can see them there clearly, that it is now showing those things gradually to us, and we can say, oh, this is what is in the result that we have gotten in a way. So now, so we can see that the results will now be about selecting what is appropriate from your output. So if you look at this output now, we first of all got our informations regarding discrete statistics out of the data. If you remember what we discussed yesterday, you can discover that we have this particular mean and standard deviations. So because I selected I want it from this analysis as well, I can get it from the system. I can get it from the system. So now we have 3.20, 1.49, and others like that. Then this is the correlations. Because I have selected that I want the correlation to be there too.
but I can't see anything on my screen. No.
Mr. BC, can you see what I'm sharing?
I can see what you are sharing.
So
I
why
can
are
only
you
see
not?
figure at the top 8104255. I don't know if that is what you are talking about.
I'm talking about the software I'm using. You cannot see SPSS.
I
I'm
can see
seeing SPSS.
SPSS.
Eh?
I can see SPSS.
So which one are you now saying you are not seeing again?
Is the software he's talking about now? We are seeing it.
Mr. BC,
Okay,
can you see?
I thought you said the result. I can't
Wait,
see
wait,
result.
wait, 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 wait. Mr. BC, can you see
Sir?
where the regression is written? Regressions. Can you see that output?
No, I'm seeing label name. I've not seen regression yet.
Okay, wait.
I'm seeing your variable view where you're showing me A1, A2, A3, A4, A5.
Wait.
And that's what I'm also seeing.
No problem.
Okay.
So can you see this?
Yes.
Yes, I can see it now.
So you can see the results.
Yeah, I can see the result now.
Yes.
So now, did you see when I was trying to run the analysis? You saw that one.
I didn't
No,
see that one. No.
I didn't see that one.
Okay, now let me delete it. Let me delete this one. If you couldn't get this, then there's no need for us to further discussing this one. So now I want to believe that you will see this now. So now the one I'm sharing now is this. Let me go to the data again. I want to share the data. Now, can you see this one?
Yes.
Yes.
So now,
Yes, SPSS.
can you see the one I click now?
Yes.
So now
Yes.
we want to run regression
Then we'll
now.
go to regression.
Then we go to
Yes.
regressions. We select
Yes.
linear. Because we
Yes.
want to run simple linear regressions. Then
Okay.
we come here and select our variables. So so we select our variables. So now, like I said the other time, I said we want to run the analysis based on independent variable one and dependent variable another one. So we are looking at simple linear regressions. So the first thing I'm going to do now is to look at this. And I said that I want us to look at the fact that when people are getting information from the news, they are probably also relaying the same information to other people who did not have the opportunity to get the information. So that is why I'm using this getting information from news sources as independent variables. So you click on this and move it to this area. Now, the first one is about getting information from people around me. So I'm taking this as dependence. So I will now move it to dependent area. Like I said, when you finish this like this, you move to statistics level. Then you select what you want to come out as your result. You can see model fits, R squared change, and descriptives. Then estimate. Last time we talked about confidence interval. So this is 95% confidence level. So with all this now, you are done with this rank selection. You click OK. Now, the next thing is that if you want plots to be there, I said you are going to select dependent into the y-axis. Then you select independent to the x-axis, like what we have here. So the next thing to do is to select whether you want nominal probability plot or histogram. But we need histogram here. We click OK, we move. Now, I also said that if you want your data to be saved, that is the output of what we are going to get now, to be saved for later use, that is for further analysis, you come here and select the one you want. Do you want predicted values to be saved? Then you select a type that you want from all this. Is it adjusted one, standardized one, unstandardized one? Then if it is residuals one, you also do the same thing and you move by click continue. Then the options we have here, we have 0.5% as our p-value. But I said that if you don't want to use the 0.5%, you have the opportunity to come here and change it to this value, or you input the one you wanted to input have there, then you move. But we want to use this. So I click OK, and then you click continue to get the result. Now, when you now get the result will look like this. So this is your result. This is your result now. So we will look at the result now. You can see those things we have selected when we are doing the inputtings. We can see the statistics already here. The mean standard deviations are here, like what we discussed yesterday. So this is our correlation table, which indicates the link between independent and dependent variable. So what we are going to get again now is to look at the link as well. Now, what we are getting here is that Pearson correlations is what? 0.516. That is the link between I get information about current events and issues from people telling me what is going on with I get information about current events and issues from the news sources is about 51.6%. If you multiply 0.516 times 100, it's going to give you 51.6%. So what we are reporting now is this. What we are reporting is the particular this please mute yourself, read one. If you are not talking, mute yourself. So what we are going to get next now is the p-value. So our p-value here is telling us that is 0.000. It means it is perfectly correlated. That means that the more people get news from from the news sources, the more they also get news from individuals. So we can say that the people who said that they are getting news from people around them, they are actually getting the news based on the fact that those people that are reporting the information to them also got the information from the news sources. So this is 51.6% linkage. Is that clear to you now? Anybody with any question on this table before I move on? Anybody with any question on this table before I move on?
It's okay.
Okay, no problem.
Hello, sir.
Okay.
Hello, sir. If the value is greater, you said since the value is 51.6, that means that people that get information from news sources, they also pass it around to those that is telling the people around them. If the value is greater than, let's say, is more than 51.6, let's say it's up to 70, or it is less than, how do we report such?
You also report it like that it is 70 something. If it is 40, if you will say the 40 as well. The idea behind this linkage is that we want to know the extent to which independent variable connect with dependent variable. Let me put this way. The extent to which A and B connect. That's what we are looking at. So in these situations now, we are seeing the news sources that people are also consuming, influencing in a way how people are also getting news from those people who have already consumed the news from the news media. So in this situation now, it is 51.6%, which is above the average. If it is less than 50, we can say that it is not absolutely okay in a way, less than 50. So from the 50 upward, it is a good result. But if it is less than 50, it's not a good result. Now, and if you look at the p-value, it means that the link that I see between the two is very significant. That's why we are having this 0.000. So that is how you are going to talk about your correlations. Now, if we go down, let's now look at the model. Whenever you are running regression analysis, in most cases, what we are talking about is model. It's about model. So our model now is that of the news sources and people also getting news from people around them. So we are trying to model it together and have a significant discussions. Now, I will explain the things that are very important on this table now. One of the things that you're going to look at here, you discover that from this first table that we have here, we have 51.6%. If you go here to, you can see the R here, the same result. So this is correlations. That is, the link between the two is 51.6%. And if you look at the A, this small A on top of this 6 now, and you check the bottom, you can see what they wrote there, predictors. That is, I get information about current event and issue from news. Predict what? Predict I get information about current event and issue from people telling me what is going on. So now the next column is R square. R square is the square of what we have as our what do you call it, as our change, F change and others issues here. I mean, in the statistics in a way. Now, the R square is telling us the extent to which we can see the predictor independent variable. For example, you can see that the regression says that it is 51.6%. But by the time you check the R square, it reduced to 26.6%. So this is telling us that the extent to which we can say that the news sources that people consume also influence the way they report what is happening to people around them is 26.6%. So in a simple terms, the idea is that what is the quantity of I get information about current event and issues from news. A, I get information about current event and issues from people telling me what is going on. So the quantity is 26.6%, which is less than average. So we can say it is not absolutely good enough. You are going to report this and also look at change statistics. If you want to report this change statistics now, you can see that we have okay, we are going to zoom to the next link later in the next few minutes. So we can see that we have significant F change here, .000, which means that for the fact that we have the link between the two, it is 51.6%. We also have 26.6% as our R square, which indicates the extent to which we can get in B, and it's very significant. So we can now agree and say that we have a perfect score in a way. Now, if you now go down, we have ANOVA. I will not talk about ANOVA in this report now because it is of note or significance to correlation reporting. What is important is this next one, coefficient. And in most cases, we usually report these coefficients, not even these model tables. So now, let me now talk about this now. If you go to this table now, you can see unstandardized coefficients. Standard coefficients. Then we have T and we have the significance level, and then we have our confidence level here now. So you can see now clearly that we have 51.6% again under the standardized coefficient. When you want to report this table now, you pay attention to this standardized coefficient better. So similar to what we have here in terms of our R connections, 51.6%, we also have the same thing here in a way. It's also significant here. So the idea here is that when you want to report, you will now say, oh, based on this, I get information about current event and issue from news sources. And the other side of, I get information about current event and issue from people telling me what is going on. We now say that 1 unit, listen clearly to this one, 1 unit of getting informations about current events and issues from news sources translates to 51.6% in people who are also getting information from people around them. Is that clear to you?
Yes.
Anybody with a question for clarity, because this is very important when you are reporting this. In a simple terms, that 1 unit of getting information from current events and issues from news sources translates to 51.6% in those people who are getting information from people around them. That is how to interpret it in a simple language. But I will advise you that you need to get a journal articles where they use these particular tables and see the way they interpreted it further. Now, let's talk about 95 confidence interval here now. Yesterday, I was describing lower bound and upper bound to you. Now, if you look at this particular, I get information about current issues and the issues from news sources now. Let's create the first one, upper bound. This 63.632 means 63.2%. It means that in our data set now, we have 380 people. I can tell you that 63.2% of the population of the sample actually agree with this statement. That's why we are getting this from the upper side. From the lower side, it is about 45%. But in reality, when we want to discuss this particular 95% confidence interval, we usually pick this upper side. So it means that in our study, you can be sure that 63.2% of the population actually got information about current events and issues from news sources. That's the idea behind this. Now, let's do the chart now. If you now look at the chart from histograms now, we can see how diverse is our data. If you remember, when we are inputting our data into the SPSS now, we talk about the fact that we have 1 to 5 in terms of our distance, our, what do you call it? Our option, strongly agree, disagree. Now, you can see that we have 2 regions. 2 regions in terms of minus section and the positive section. So -3, -2, -1. Then we also have +1, +2, +3 on this histogram. If you look at this line now, you can see that it actually moved towards middle point. So yesterday, if you remember the mean value we talked about yesterday, we discovered that we are seeing about 3 point something, and then we look at where we see like something close to 2 point something as well in a way. So that is why we have -3 and +3 here, because majority of our mean value is around this particular area of minus and plus. Is that clear to you?
Yes.
Hello? Okay. Now, it's not in all cases you are going to report this diagram. So mostly we are focusing on this particular coefficient table and also this model. So when you are reporting, we report this and this together. So I will share one of my papers that we published, and then we use this particular methods there, so you can see the way it was interpreted. Now, if you go back to this table now, this is scatter plot that actually shows the places of those things that we have chosen for the correspondent or our respondents in a way. Now, if you look at this diagram now, there is no clear link. It means that we don't have perfect correlations. We don't have perfect correlations from this diagram. If we have the sign moving towards the left side, we can see negative correlations. If we have it towards the positive side and it is moving like this, up like this, not scatter like this, we can say positive correlations. But if it's like this to the left side, it is negative correlations. But what you are having here is not even going to either of the two. So it is actually a loose one in a way. So this diagram tells us most about the data we have inputted on top already. Now, any questions? Any questions?
So I have question.
Okay, so I can hear you.
On in reporting this histogram.
I can hear you. Continue because we have less than 2 minutes here.
The reason why negative is there is not clear to me, sir.
I have told you now that if you check the previous data we had yesterday, if you go back, for example, now we have 3.20 as the mean value here, 3.18
Yes.
as a mean value here. So
Yes.
what we are going to have actually is going to be within this region, -3 and +3. If we have our p value, our mean to be above 3, we are going to have it up to 4. That's the idea of this histogram here now. It's the selection of the mean. The mean is what we are using here to show this diagram. Is that clear?
Is the graph not is it not dependent variable plotted against independent variable? Is
Yes,
that
of
not
course.
so?
Yes, of course.
Although I will
Yes.
still go back to it, but it's not clear to me.
I have showed you this table. We have 3.20 here, 3.18. That's the mean. If you check the histogram now, you can see that we have mean here is equal to -1.23 and also going like that. The standard deviation is 0.9.
How do I pick the mean from the histogram here now?
Okay, can you see the mean value here on top of the histogram now? By the right side, can you see this mean?
Yes, I
Before
can
minus.
see it. I can see it.
So that is the
I can
mean.
see it.
That's the mean for that variable. The standard deviation is equal to 0.099. Then we have our total population to be 380.
Sir, you didn't get the question.
What is the
I
question?
said, mere looking at the histogram now. If you didn't indicate the mean here or the standard deviation, how do I just take the reading of the mean from the histogram?
It is not possible that the histogram will
It's
come
not
out
possible.
to. No,
Okay.
wait. It's not possible that will come out with you for you without bringing this mean as a deviation for you. It must be on the chart. So let's join through the next link that I sent to you.